Okay, so please read question 2. It's correct. Read question 2. Read what you have for question 2. Let's be fast. Anyone, you notice that there are some questions there that is the same with the one we solved on Monday. Shebi? So if you notice those ones, you don't read that one. You've already solved it. So you read the next one. So read question 2. Because let's be fast. You know it's my time you are consuming. I know you once it's fun and you start misbehaving. Tell me, question 2. How far? Okay, I've solved number 2 before. But which one now? Question 4. What is it? If you were not here on the dinner and first class, check your notes to see how we did it. Let me see number 4 question. Okay, let's start. We saw number 3 before. We saw number 3 on Monday. The person that said number 4 is correct. We saw number 3 on Monday. Check their notes. So they said 3 charges. 3 charged particles. Q1, Q2, Q3, number 4. Lie on a straight line. Such that the separations between Q1 and Q2 and between Q2 and Q3, the separation between Q1 and Q2 and between Q2 and Q3 are equal. So let's say this is R, this is also R. Yes, 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 yes. So let's say if I have like 2 here, this is also 2. You see that? If I have like 1 here, this is also 1. So I'm just trying to interpret. We've not started something, but they did not give us anything for the separation. If Q1 and Q2 are fixed, if Q1 and Q2 are fixed, Q1, Q2 are fixed, that is, there are source charges. If Q1 and Q2 are fixed, but though Q3 is free to move, Q3 is a test charge. It does not because of, do you know what they are telling you here? It's the same thing we're talking about. Q3 is free to move. Q1 and Q2 are fixed. Q3 is free to move, but it does not because of its calling force to Q1 and Q2. That is, it gets attracted to Q1 and to Q2. You need to note this. It's not every time they tell you test or source. They can tell you due to or on. Who is the other piece? Okay. So they said it's free to move. It does not because of this calling forces with Q1 and Q2. Then I said, show that I've not started solving, I'm just interpreting this. Show that Q1 is equal to 4Q2. Okay. So that means Q1 to Q2 is equals to R, and Q2 to Q3. Did I say it like Q2 to okay. Q1 to Q2 is R. Q2 to Q3, I'm coming, is R. Now, Q1 To Q3 income? 2R. Is it true? Okay, very important to note this. Shall we see how I'm doing it? That's how you're doing your own. You will always know when the problem is here force that is causing what is happening. Or is it distance that is changing? Or is it to prove something? Or is it that there is a ratio? Just like the last question we saw when they said, if distance is reduced to 1/3, let me teach you one manner for anything 1/3 or 1/4. For example, notice that F is equals to KQ squared all over R squared, shall we? Is it not true? The minute this distance gets reduced to 1/4, I want you to do for me, 4 squared is what? 16. Force will be multiplied 16. The new force will be 16 times. The minute a question is given to you, they tell you that the distance is reduced to 1/3. Is it not true? If you reverse this now, what are you having? 3 squared, which is 9, shall we? Force will be increased 9 times. The new force will be 9 times. If the day is reduced to 1/5, you will see questions like this. You don't have to solve it. 1/5 the distance. All you just need to do is square that 5. Force will be what? Very simple, very important. So note that. So we don't have to be solving questions that has to do with reduced to or increased to. If the day distance is increased as well, the same principle. What you can do is to do what? Let's do this way. It's increased to 1/4, shall we?
Yes.
All I need to do is to say 4 squared is 16, right? That means that my force is going to be decreasing 16 times. Is it making sense? It's not going to be, if this is going to be increased, notice that if it's increased, it's no longer 1/4 now. It's like, maybe I'm saying that my distance now is like 4 squared. Is it not? That means that this force, the new force, not this one though, the new force you're going to be doing is not going to be 1/16. Note that. You don't have to be solving any question that has to do with decreased or increased. Go and put it somewhere, practice on it, memorize it. Let that one sink and enter you. So this one now is a case where we are proving. For any case that involves proving, last year I was hoping that we'll teach you finish before we do man. But how we'll be doing it now is as I'm teaching you. Any of the man I'm supposed to show you, I will show you immediately. You note it. Go and practice it. Now see, for when it has to do with proving, what you will always note for proving is you will always check the distances and the force is there. Is it given to you? Then the charge. Because according to Coulomb's law, point charge and principle of superposition, that's what we're always using when we are solving questions like this. You ask yourself, the force, is it given? If force is not given, you now ask yourself, charge, was it given? Was anything given for it? If it's not given, distance, was it given? If it's not given, the next thing to be asking yourself is now, how far apart or how do you compare the things you have? And what do I mean? For example, this Q1, Q2, and Q3 given to me. Notice that what I've done here is to find the distance from Q1 to Q2. Find the distance from Q2 to Q3. Then find the distance from Q1 to Q3. It's just like your mass, where you do power law. You are finding how many subsets you have. When you do that 2 raised to power n now, is it not true? Your power sets in physics, where you do something like 2 raised to power n. If they have like 3 sets, you do like 2 raised to power 3, which means that the numbers of subsets will be 8. Shall we? That's the same approach I'm using here. So what I'm just doing is to find the distances. Then I'm not going to be asking myself, which one is actually my test charge? Which one is actually my test charge? Because Q2 and Q3, sorry, Q1 and Q2, they are fixed already. They are fixed. So I don't have reason, I don't have business with this distance. They are fixed. If you remember, I told you you can have many source charges and just only one test charge. So for the fact that this and this, they are fixed, they are source charge, this will attract this. This will attract this. That is if they are opposite charges. And if they are the same charges, it will repel this, this will also repel this. So what I mean, the principle, the approach, the main thing I'm trying to point out here is that in doing this, you are checking what is the distance from Q1 to Q3. That is the thing, all this English I'm speaking. And what is the distance from Q2 to Q3? That is what you are checking, because Q3 is given to you as a test charge. It's given to you as a test charge. It is the one that is being affected. It is one that will either be drawn or repelled. The same thing here, drawn or repelled. So Q1 and Q2 cannot attract themselves. They are fixed. The question told you they are fixed. Forget the fact that the way I put it, you are seeing it and it's looking as if they are close. They are not close because they told you it's fixed. They are source charges. And you need to know that it's not every time your test charge will come and be in the middle. Once they tell you something is a test charge, just have it in mind that that means that this particular charge can be drawn to this and can be drawn to this. But this one that is a source charge creates its own electric field. This one creates its own electric field. This one, the electric field it creates is very small, so it has to be drawn. Note it. Don't mistake it. Some students mistake it because they want it to be that if it's true, you should have Q3 like this, in this case, so that this can go here, this can go here. No, it's not every time it's like that. That's the point I'm trying to make. So if I've noted this, the next thing I need to do now is I want to clean. I can clean, right? So I can go on to solve the questions, but I just want you to know this because it's not every time they give you this same question, but whenever they give it, however they give it, using the same principle and the reasons why I am using what I'm using, you will always be able to solve. These are source charges. I have no business checking its distance to each other, provided what I'm doing is to prove something. So that means that I am simply focusing on Q2 to Q3 and Q1 to Q3. So if you read that question, you will see that those are the ones fixed, Q1 and Q2. So what I want to do is to say for Q1, solving for Q1, since there is common force of attraction on Q3, so this is going to be force on charge 3. Force on charge 3 due to 1. Do you remember when I told you in our last class that the test charge always comes last and the source charge always comes first? So force on charge 3 due to charge 1 is going to be equal to something. You notice that we normally have Q, that time you do Q1, Q2, or maybe Q and Q naught all over R specially. But this time around, what you are not going to be having now is going to be your source charge here is what? Q1, Shebi. Your test charge income? Q3. Are you seeing it? Now, please, the distance from Q1 to Q3 is what? 2R. But notice something. My arrow here, you see, if you remember, it's always squared now, Shebi. Yes. So this is going to be 2R squared. So that is for that one. Then, okay, if I do this properly, I should be having KQ. Don't make the mistake of saying Q square in this case. Once you have a test charge and a source charge, even without being told, the one that is source because it's bigger. The one that is test because it's smaller. So you need to know if you don't come and do that, it's the same and do Q square in this case. So I have Q1, Q3. All over. These two square will be what? Then arrow. Okay. So that will be that for force on charge 3 due to charge 1. Now let's do force on charge
3
due to charge 2, Shebi? Yes. And remember I told you that the test charge will always be last. That's coming up. So I will now have KQ 2, Shebi? And then Q what? 3. All over arrow square. But then, tell me, the distance from Q2 to Q3 is what? R. Okay. That means I'm in order. Like this. So I just leave it as arrow, then it's always going to be straight. So that F2, 3, It's just what it is. So I have it this way. Now, remember they told me to prove something that Q1 is equals to what? 4Q Q2. Or is it Q squared? 4Q2. Okay. So please, at this junction I can now compare. I can now compare the two. Remember, notice, why am I comparing? This is a test charge. This is also a test charge. Is it not true? I told you always have one test charge. You can have as many source charge as possible. So I can now have this to be the setting as saying F13 equals to F23. So checking this out, I'm not going to be having KQ1Q3 all over 4R squared is equals to over R squared, shall we? But when we cancel, this can take care of this. Is it true? Any other thing can take it? This can, shall we? They can cancel K, right? Check if I'm still in order. So I'm now having equals to Q2, shall we? Sharp. Anything on this one is over 1. So cross multiply. This can be sent as saying Q1 equals to 4Q2. Very simple. Very simple. No stress. The only stress you will have is if you don't know what is test charge and source charge. Because the minute you don't know what is test charge and source charge, your mind will just be on if it's Q and Q, maybe Q1, Q2. What are you now doing? Somebody might even say, put Q1 and Q2 here together. Then put Q2 and Q3 here together. Because you don't understand what is source and what is test. So once you understand source, you understand test charge, you have no issues with this one. So that is that. So remember I said we have no business with this. Let me look at that things. Okay, that means that's all. Okay, what I will do is, by the time I get to number 7, if we have time, I will now go back and solve all those ones that was not done before, so that I can prove something with that force, why we are always comparing the forces. So define electric field strength. You know what electric field strength is, right? What the electric field strength is? But as a physics student, you can say it is the force per unit charge. If you now want to explain it to yourself, you now tell yourself that it's simply the force acting on a charge in an electric field. So if I've noted that, they said if an electron is driven by an electric if an electron is driven by an electric field of strength E equals to 4.8 times 10⁻⁻⁴ volt per meter, calculate the force on the electron. Acceleration of the electron, the distance moved under this field in the first 2 seconds. But let's do it. If an electron is driven by an electric field, calculate the force on the electron. Let's do it. Should your phone don't use to lock? Does it lock? Yes. It locks. Okay, you say, gear phone, you must lock. I've been typing it, I want to copy out what I need. Instead, I forgot. I've not seen a gear phone that don't use to lock. Or hold it, be reading it out, let me write it. Another thing that gears don't like is you holding their phone. Once you are holding a gear's phone, there's trouble. Like longer than you should. Oh yeah, read. Let me just write what I need out from the question. Read from the first part, electric field given. Okay, wait. Electron is driven by an electric field.
Of strength.
Electric field of strength.
E equals to
equals to 4.8
times 10 minus 4. Vm minus. Calculate. Calculate the force on the electron.
Force on the electron.
Acceleration of the electron.
Acceleration.
The distance moved by the electron. Under this field in the first 2 seconds.
In the first 2
seconds.
Okay, that's all should be.
Take the mass.
Okay, mass.
Of the electron.
Okay, mass of electron.
To the 9.1. Times 10 raised to minus 1 kg.
Is it 91?
9.1.
9.1 times 10 raised to power minus what?
91.
Okay.
kg.
Okay. Is that all?
Yes.
Okay. Are you through? Are you through? So you write solution. I've told you before, there are some things you don't know inside the exam hall. Once you write solution one place, your fine handwriting there, inspiration will enter. So let me bring out the things I have. I have E equals to 4.8 times 10 raised to power minus 4. Okay, please, did they give us any? Notice that this person did not give us any distance, Shebi? So in this case, what I'm just going to be using is this principle. Force equals to charge times E. Do you remember in our last class, I gave you a formula for quantization? Yes. Where I said Q equals to what? That is number of electrons, Shebi? And that this number of electrons can be, should I say, integers. So especially when they ask you to find number of electrons, you always remember this. So I now have my F to be equals to. Somebody wants to ask me, but they did not give us charge for electron. Shebi? But we know that we know the formula for electron. Is it not clear? This one was direct. So I'm going to be using, it's not like they just mentioned charge. So I'm going to be using 1.6 times 10 raised to power minus 19. Yes. And have you noticed that there are some things that even if you don't know the formula, once you know what it talks about all the time, you always get it. And you notice that anything you're talking about force is always in a product form. So you've noticed. The same thing with, what's it called? No, not acceleration. Momentum. Momentum L. That is linear momentum and that is mass times velocity. And momentum is always in product form as well. No, density is always in ratio form. Just like as we progress in our charge distribution class, I'll be telling you about what we call linear charge. Linear charge density. When I have this to be Q over L. Then surface charge density. When I have this to be Q over A. Then volume density. When I have this to be charge over volume. So in this particular case, charge can be equals to lambda L. In this particular case, charge can be equals to surface density area. And in this particular case, charge can be equals to volume density V. So these are things I'll still teach you. But density, anything density is always in ratio. This is part of what I'll teach you in charge distribution. So on Monday, times 4.8 times 10 square minus 1. One punch from me, what do you have? 7 points. 23 Newton. Shall you still? Once it starts, you tell me. I want it to be so I can post. But I've noticed something. I've noticed that videos that we post, people think it's funny you are doing it. It's for you because in my mind, you know how I always feel? I always feel that I won't be able to even teach you like everything I feel you should know in this course in just one class. But if you notice, we're always doing it as if we're trying to do everything in one class and go to another thing. And that is why if you've paid attention to the videos, you see that most of the things I teach there are some deep similarities, but they are not entirely the same with what I teach you in class. If you are following it. So it's up to you, it's a choice thing. My own is that I'll still try to teach in class. But if you now feel you really want to put all your best, always go through the videos, it helps. So the acceleration is simply applying that principle. Applying the principle where I said that F equals to QE is the same thing as saying MA equals to QE. If you remember, without stress, so I can now do divided by M. So this is the same thing as saying MA equals to, and QE is giving me 7.68 times 10 raised to power minus 23. So divide by M, and M is equals to 9 minus 31, shall we? Yeah. I have one for me. 8.44. 8.44. Okay. Meter per second square. Now, please, somebody might want to ask me, but how come you know the formula you are using? It's looking as if we gave you so many formulas, now we are choosing just one. Now, see here, once you look at the question is what determines the formula you are using. There's nothing special case happening here. It's just like when a question is given to you, everything that can happen for you to use the other formula, is still happening, you know. But in this case, question given to you is telling you don't pay attention to the other things. Using what you have, which formula can you remember? So if you check it, the reason I did not come to start doing that E equals to KQ over R squared is because I don't have R given to me for that issue. I don't have R. I know this one is constant, and I know I have charge, but no R. So in this case, no need stressing myself. I just go to the first rule. And notice that if you still check it, the first they're asking is even first they're asking me. So I'm supposed to even be thinking of this one, not E. That is KQ squared over R squared, which is the same thing, no R there. So always have it in mind that the question is what determines the formula you are using. Not like maybe there is a special thing kept there that you must use this one. However, the question called determines what you are answering. So if they ask me to find distance moved by the electron under this field in the first 2 seconds, what they are just telling me is kinematics. They are using style to point me to kinematics. We are using style to contribute to kinematics. That is, you remember S equals to UT plus half the AT squared and shading? Yeah. So this kind of question, you always see it. Alright, so what I'm using is at initial states, electron should be 0 from rest now. So I'm having everything here to be out. So what I'm using for the distance in the first 2 seconds is simply half AT squared. S is going to be half. My acceleration is 8.44 shading. Times 10 raised to the power 7. Then times, my time is 2 seconds. It's not the first 2 seconds. Notice that this is raised to the power 2. And your punch for me, S is what?
1.69 times 3 to the power 8.
1.69
times 3.
10 raised to the power 8. Okay, meter. Less. Somebody will be somewhere asking himself, how did all this one enter the law? Which one is not the distance inside the law? That's what I'm saying. That's what I'm saying. If you check everything we've solved so far from beginning, we did not make room for calculating distance in the electric field or whatever. So whenever they ask you distance, have in mind that what they're asking is to use kinematics principle to find that out. Okay. So let me see where you're from. So the one we solved now, is number 5. So the next one we are solving is number 6. Number 6, calculate the positive total force between protons, 2 protons in the nucleus of zinc. Okay, this one is simple now, but let's do it. This one is the normal principle. They are just telling us to use the normal principle. Can I claim? This one is just telling us to use the normal principle. Are you tired?
Yes.
Read. Once we get to number 7, we go home. Read. This is number 6. Shall we be a science student?
No.
You don't want to be a science student? Yes. That's been playing. You will not go. Shall we? Did you notice that people, hello? Did you notice that those of them in Park Lane, some of them now move to, is it what we call C1 class? Are you aware? Now imagine you that is here doing this small thing you are doing. If you don't build the habit of you suffering as a science student now, imagine when you might get there. Shebi, you saw that one boy that was saying, I made it. You saw how slim he was looking. It will take that boy like 2 weeks to recover. Because before that he's I made it, every night he's reading. No serious phone call, no happiness. You just be reading, wait for. So you will build all those habits now. So that when you get there, it will not be hard. And if you think people don't fail, like everybody is saying successful, it's a lie. If you check deep, you see people that failed inside. So please, take it that what we are doing now is still enjoyment. I tell you, we are still enjoying ourselves. The time will come when you won't have time to be enjoying like this. That's why they tell you in your year 1, you have the most, should I say the most free time you have from 200 level. Combined with your GP that might be shaking, but your own will not shake in Jesus' name. Yeah. Then plus the stress of 200 level. You will see now. So that's why we say 100 level is very peaceful. Enjoyment. 200 level, very enjoyment too. You will be looking at ShopRite, you will be asking yourself, why don't I go to ShopRite? You know ShopRite is close to Park Lane. Even when you have the money, you never ask yourself, why is it that each time I go to ShopRite, I don't feel like somebody that went to ShopRite? It happens. It's just like those days in secondary school when you're about to write JAM. During that week of JAM, no matter what happened, no matter how your friends came close to you, that you're supposed to feel excitement like you used to, you won't be feeling that way. Unless you did not write jam yourself. But if you did yourself, you notice that it changes your mood. That's the same way you'll be feeling that time in 200 level. Because every time is seriousness. I read. Question 6.
Calculate the repulsive total force.
Calculate
The repulsive total force.
column force. Columns force. Between two protons.
In the nucleus of zinc.
Of zinc.
If the distance of separation
In the distance of separation, the arm of separation
between the protons is equals to 3.7 times 10 minus 10.
is 3.7
3.7 times 10 raised to the minus 10. 10 cm.
cm. Is that all? Is that all? So what are we looking for? Okay, the repulsive force. Please check. Is this question complete? Check.
Between the
Okay, so what I'm using is simply F equals to KQ square all over arrow square. This is what I'm using. Because notice something. They're talking about protons. Is it not true? Yes. And this repulsive force between two protons, they did not tell me that the one proton is different from the other. So in that case, I'm using KQ square, not Q1 or Q2, no test charge, no source charge. They are all source charge. So if the radius of separation given to me, so this is what I'm using. So I'll just do to find F, just come and substitute F equals to K is a constant, which is 9 times 10 raised to the power 9. Shaping? Which you know that we get it from 1 over 4 pi epsilon naught, and this epsilon naught, the productivity of physics is 8.85 times 10 raised to the power minus 12. If we do 1 over 4 times 22 over 7 times this, we should get this. That's what they are saying. Yes. So I now have Q squared. Charge of proton is the same thing as charge of electron, shall we? Yes. And we know that the charge of proton and electron is 1.6. 19, shall we? Now, between electron and proton, which one travels faster? One. It's lighter, shall we? Yes. Sharp. That means that proton has more mass than electron. Yes. Okay. So I have square, shall we? So I have 3.7 times 10 raised to the power minus 13. But notice something. This is in cm. Shall we? Okay, so I have
3 is minus 15.
I know. Times 10 raised to the power minus 13, shall we? All over 100. I know. Because I know that there are people that need me to do what I'm doing. So converting cm to meter divided by 100, which is the same thing as saying 10 raised to the power minus 2. Shall we? Which is now going to be 3. Is it? Yes, those. Yes. 3.7 times 10 raised to the power minus 13. If this is coming over, it becomes minus 2, which is what I need. So it was 3.7 times 10 raised to the power. So I put it here, that is in meter now. So I put it here, 3.7 times 10 raised to the power minus 15. All square. Punch for me, what do you have?
6.23 times 10.
Everything. 6 points.
Times 10 raised to the power minus 4.
Times 10 raised to the power minus 4. 14. Okay. Like this.
Yes.
Please be sure. 16.8. Thank God it's not only two people that used to come for tutorials. Imagine if we are making video and it's only two people that come for tutorial. One is with calculator, the other one don't have calculator. The whole world will just be shouting hey for us. So please, watch it well. You should have 16.8. Watch it well. That's for number 6. And you know the advantage this semester has? This particular semester, the advantage is that it's not like the last semester. Last semester was touching many things. This semester is just focused on something. This semester is just direct. If it's not electricity, all the concepts is magnetism. And every concept of magnetism is the same with every concept of electricity is the same with magnetism. Just that certain things will be changing, like the symbols will be changing. And slightly, for example, if I know that where this one is having an angle that is 90, this one might come and have the same angle, just maybe 45 or at 0. So it's almost the same thing. So we get there. That's why I say this semester work is simpler. So 6 words now, 6B. Number what now? Number 7A. I'm trying to be fast. Somebody said be fast now. Human beings. About human beings. Ah, God. I read number 7A for me. Read that number 7A to me. Let me hear. What do you have for number 7? And what?
It's whether it's a vector or a scalar.
Okay.
So it's potential.
Do you know the advantage we have for this class? The advantage we have is that we are just starting. Please, this period that we are just starting, take your time to revise this. Not if you finish, you keep your notes. Say on Monday, volunteer. You say you learn it in class. You don't have the spirit at home. It will not sing. You revise it at home. Even if you are tired, small revising, it will be ended. You don't have to do it plenty at the same time. Now see something. The same potential. We've touched it. Why I'm touching this is because they asked if it's scalar and if the other one is this. Then this one is electric field strength, shall we? For me to be talking about field strength, it's the electric field now.
Yeah.
It's not gravitational field strength you are looking at. So it's electric field strength. Note that. So electric potential talks about work done in moving a unit positive charge. Electric field strength talks about force per unit charge, or you say force acting on a charge in an electric field. So if I know that it's not force created by or force acting on charge, no, it has to do, electric field strength has to do with source charge. That is in that case, or when you're talking about that force that relates source charge. I know we'll pass through this one, I don't want to define it again. What I'm telling you is if it's a scalar, see something, work over charge. Do you remember that I said F equals to MA? That charge replaces mass. Acceleration replaces E. Do you agree? Yes. Mass is here a scalar quantity. Yes. It's a scalar quantity. That means that charge is also a scalar quantity. Are you getting it now? While acceleration is here a vector quantity. Yes. That means that electric field intensity is also a vector quantity. Note that. So this one is a vector quantity. I will note this one. If you don't want to notice that one, another way to note it is to say force over charge. Is it not true? When you have vector over scalar, Is it not vector you are having?
Yes.
You are having vector. Now this is a scalar quantity. Do you remember what is a scalar? And this is a charge, scalar. Shall we? Scalar over scalar? Or you say scalar, whichever one. So, that's if you like to play. So, the answer is that potential is a scalar quantity, electric field is a vector quantity. So, may I pronounce it as scalar? Your textbook might tell you scalar. I don't know. But somebody one time said you are pronouncing it emotically. That is scalar. So please, that's the answer. So any other thing?
B 7B.
7B. I can do it, right?
No.
So if you are done with 7B and you permit us, we will check any question you feel is the hardest one in that question and solve, then you go. Or do you want to go?
Yes.
You are doing yourself. Oh. Okay.
Yes.
Okay, you are doing yourself. Yes, you are doing yourself. Okay. Continue Human beings. In this world. Fire, give me 7B.
The points A, B, and C form an equilateral triangle.
Points A, B,
and C form an equilateral triangle.
An equilateral triangle.
Of size Z. Point charges of equal magnitude of Q.
Point charges of equal
Magnitude of Q.
Of Q
Are placed at A and B.
are placed
At A and B.
and B, yes.
Find the electric field strength and the potential
Electric field strength and potential, yes.
at C.
At C. Is that all?
Due to these charges when
When
both charges are positive. The charge A is positive and B is negative.
Okay. Is that all? Okay. So there we have it. So since I'm using our time, you don't want us to use your own time. Let's be fast. Then. See, the points A, B, C form an equilateral triangle. Let me have this to be nice. Equilateral triangle. Let's say this is A, let's say this is B, and let's say this is C. How I wish you are not solving questions, but you're understanding this thing. It will make more sense. This is Z, Z, Z. The points A, B, and C form an equilateral of size Z. The sides of an equilateral are equal. Point charges of equal magnitude of Q are placed at A and B. That means I have Q here. Equal magnitude, if it's positive, because they said charge and not electron, I'm using positive. So I'm using plus Q plus Q. Okay, but they already told me that they have cases, so no need. Let me just have Q magnitude. There's none at C. There's none at C. The charges are at A and B. The confusion students have is that they think the charge is at C and A and B. The charge is at A and the charge is at B only. Now they say we should find electric field strength and we should find potential. Electric field strength and potential. Very important. Now see something. See something. If that be the case, the angle here will be what? Angle what is here? What angle is here? What angle is here? Is it 60 degrees? Okay. So we say case 1. That is I when both charges are positive, when both charges are positive, both charges positive, notice what will happen. Please watch something. Do you agree that I will draw this thing because I'll still clean it? C, Q positive, this place positive. Do you know what will happen? This charge will move. Let's say this is a charge now, and this is charge Q. This charge pointing away, positive charge is pointing away. And you know that you cannot come here because it will be repaired and it's not true. Yes. So it is stopping here. Why this charge now pointing away as well? Are you aware? Very important. Somebody might want to ask me, what about here? What will happen here? They can't come together because if you check it at this end, you are going your way, I am going my way. We don't have business, they are rebelling. So you don't consider this end. So see what is happening here. The two charges you have, they are both coming to C. That is what it means. They are coming to C to meet. That is, the end point of this charge is going to be at C. Can you hear me? The end point of this charge is going to be at C because this charge cannot flow to this one. And this cannot flow to this one. So whatever settlement this one finds in C, that is the same settlement this one is finding in C. Whatever you place in this point of C, that is what these two will take as in this, it will take the effect of these two at this point. So the only place charging is happening, or the only place electric field is happening in consideration is actually at this point. And that means that the only angle I'm looking at when I'm talking about this is 60 degrees. I've not started finding the electric field. First, I'm finding an angle. Reason being that anytime triangle is given to you, and you don't know the three sides, or you already know the angles, that is 60 degrees, but you don't know the three sides, there are rules you must employ. So I cannot start solving without first of all saying, okay, when I don't know the three sides of a triangle, they call it Z, but I don't know it. What rule do I make use of? That is what we call resolution of vector. And that resolution of vector is that one law that gave us cosine rule. You remember first semester, when I told you either we use resolution of vector or we use cosine rule, the resolution of vector makes room for us to solve if it's more than two vectors. But when it's cosine rule, it's going to be maybe two vectors I'm talking about. Do you still remember? Yes. If you don't remember, forget about it. For now, the charge is moving from A and then moving from B and coming to C. The only angle I'm considering when it's positive is just 60 degrees. Shall we? Yeah. Now, when you've copied this, because I copied this so that I'll be able to analyze this. So let me just clean this part. That's this part. Let me analyze the B part. So I when A is positive and B is negative, notice something. Watch this. I want you to watch this so you see what is happening here. It's not magic. B is negative. A is positive. Then there's no charge on C. C is like settlement point. But notice something. The minute this charge moves, negative charge itself that wants to move, we now remember that negative does not point outward. Is it not true? Yes. Rather, it points inward. So whatever is happening to this negative charge is actually going to be flowing like this. Are you getting it? It's inward. It doesn't flow out, but it's going to be from this side. Positive is coming in. And on this side is also inward. That means the positive you have here is actually going to cross this and coming down here. Are you getting it? So there is no settlement here. This angle, there is nothing for this angle. Rather, it moves from the first 60 degrees. Watch you. It moves, the charge is moved because attraction will occur. When you have positive and negative, attraction will occur. So it moves from the positive, then it gets attracted to the negative. It's coming down. So notice another thing. This is also 60 degrees, shall we? Now ask yourself, charge is inside the triangle is how many? Is it 120 or 180? 180, right? But notice that nothing is happening at this angle, right?
Yes.
Zero. Yes. That means that the angle I have for this particular part, whenever I am having a triangle and charges are moving from both ends, what I'm going to be having is angles inside the triangle, 180 degrees, and nothing happened here, minus this 60 degrees and nothing happened. The angle I'm making use of here is 120 degrees. If you don't want to consider it this way, you tell yourself there is 60 degrees for the positive, there's another 60 degrees for the negative, 60, 60. 120. If you don't want to consider it that way, angles in a triangle 180 minus the angle where nothing is happening. There's no settlement here. This is 120 degrees. You found that out. Very important. You find the angles out. Because these questions are not questions that give you once and that is it. You can see it in different places. Once you hear that there are two charges and there's a triangle and there are two charges moving positive, positive, know it that the angle is just going to be one, where it's going to settle. And when they say there are two charges, and one is positive, one is negative, it's going to complete the law. But nothing is happening at that angle in the middle. That is what we've done here. So now that we've found the angle, let's now find the electric field. And then the potential. Can I claim? And notice something, so that I don't rush and forget. Do you remember we said that? Okay, let's one step at a time for some people. Can I claim?
Yes.
How we got the angle, you understand, right?
Yes.
But let me claim. These questions is not something you solve once, you forget these things I'm saying because they are important. Once you see cases like that, you don't need to be killing yourself again. You just know that this is what you're supposed to do. Go your way. So, I am considering case 1 to find the electric field in case 1. I'm going to be having using cosine rule. Using cosine rule. It's a triangle, and I have my triangle to be A, B, and C. This is the angle I'm having, 60 degrees. Do you remember I said electric field is the center with electric field strength? Just that electric field strength describes electric field. And you remember that there is a vector. Electric field, electric field strength, they are vector. Now, if that be the case, the minute you have a charge here, and it's not a test charge, a source charge, what do you think will happen? Electric field is created here, is it not true? Do you agree? Yes, now let me use small e. The minute you have this, electric field is created here. If you have this as well, electric field is created here. That's checking the first case. What did you say? No, if you want to use big, you know, I'm just using so that you'll be able to see what I'm doing. Now, at this point where they come together and settle, notice that there's no test charge. They do not say test charge. At this region, electric field is also created because these charges cannot meet. So there's an electric field on this as well. So let me call this one EA. But let me use big EA. EB and EC, electric field, and remember we said we use field lines to show the movement of charge, or we said movement of electric field. If you remember, what I'm using here are field lines. I'm using field lines to show you how it's moving. Anywhere you see field line, it means that electric field can be there. Your electric field is moving from here to this place. Somebody might want to say, why is the electric field not one place, since the charge is one place? Provided they told you that there is another charge here, and this particular thing is connected, that means there should be flow, work should be done, electric potential should take place. And if this charge is supposed to flow, as it's flowing for each region that it is flowing to, electric field is being created at that region. So as it's flowing, at this point, you are going to be having electric field C, electric field A, and electric field B. That's the point I want to get there to enter you. They told me here is Z. They told me here is Z. They told me here is Z, but I don't know what it is. So I will simply say, since I don't know those sizes, I don't know the size, I will use cosine rule so that I have from that principle of f squared. Yes, f squared equals to, or you say r squared equals to x squared plus y squared plus 2xy cos theta. Shebi? Somebody was saying minus. Do you remember that each time we put minus here, we always make sure that whatever angle here is going to be above 90? Is it not true? So that at the end of the day, we get positive. Is it not true? Which means that a situation where the angle we know for that first case is less than 90. Me going to put minus here will give me a negative value. So what I'm having here is plus. Am I confusing you? Just cosine rule. Just cosine rule. Cosine rule is structured in such a way that the endpoint should have the x squared and y squared to be added to the part with the angle. So a situation whereby I have an angle less than 90, if I go and use that minus we are talking about, that is why I said that parallelogram rule and cosine rule, they are the same thing. That the parallelogram rule that gives you minus is always trying to make everything at the end of the day to add up to stay have positive there. So that is why, please, I'm using plus. Go and study it. Study what we did in first semester. Study it. You see that at the end of the day it's supposed to be this way. So I don't want to put minus here. Then when I use 60, it's positive. I'm going to end up having negative value, which is wrong. So r squared or r. So instead of r here, please, the resultant is simply the total electric field. Resultant here is simply the total electric field. Notice that the electric field here is the one at A, this one is the one at C, this one is the one at B. The resultant here is simply the total electric field, which is my E. The E net is going to be the one on X now. I'm saying, let's say this is now my A, the electric field on A squared, the one on B squared, and EA, EB, then cos theta. Or you say EC instead of EA, EB, that means EC. Should be, but in that case it will be square. So let me just use EA, EB. Hope I'm not confusing you. Am I confusing you? No. Okay, so please let's do this one. So this is going to be EA squared plus EB squared plus 2EA EB cos 60 degrees. So just follow me. Just follow me. At the end of the day, cos 60, check for me cos 60, what do you have? Is it half? Is it half? Yes. It's the same as half. So I'm having plus 2EA EB times 1/2. This will take care of this one. Cos 60 is half now.
Yes.
Cos 60 is the same as cos 30. Sin 30 sorry ahead. So I'm having EB squared plus EA squared equals to E net. So you see that I'm left with E net equals to EA squared plus EB squared plus EA EB. Okay. At this junction, we remember that electric field intensity here. Remember that this A has no effect. It's just telling us where the electric field is. Do you remember? Because somebody will be somewhere already saying, okay, EA electric flux, EB, please. The A here is just telling me this electric field is the one at A, this one is the one at B, this one is the one at C. Please note it. So if that being the case, I remember that electric field intensity, if you remember, is the same as saying E equals to KQ over R squared. This is when charge is a source charge. Is it not true?
Yeah.
Why the other one is when it's a testing charge? And please, this question, these are source charges. Is it not true?
Yeah.
So that is, I'm going to be using this one. Don't confuse it. Know when you are using for source charge, when you are using for test charge. So that is, for here, I can easily say, let this become KQ over R squared plus KQ, and notice, okay, Shebi is squared. And do you remember that this one is also squared? This is also squared, Shebi? I think before I even start putting this in, let me introduce that square roots. Because it will look plenty. So let's say the square root, square cross sign. The square root will now come. Hope I'm not confusing anybody.
No.
So it has crossed. So now that I have this, I will use this because they are source charges, not testing charges. They are somewhere already emanating electric field. So my total E net E will be equals to root what? I have how many electric fields do I have here now? Let's check. Let's do it this way first. KQ over R squared all squared. This one is for the one on A plus KQ or R squared. This one is the one on B. Then plus KQ or R squared. So see something. Notice so. So you see that this is like two things now. This is for A, this is for B. We are just saying that the electric field on this, and notice that these two charges are positive. Shall you remember? I don't want to confuse you. That is why I'm taking my time to do it like this. So that there will be no assumption. So that there will be no assumption or imagination. You saw all the steps. Now please, if there is positive charge on A and there is positive charge on B, that means they are the same charges. And they will repel each other. Is it not true? So whether I call it A or B, it's the same charge. So for that reason, I will simply come here now. Start to ignore the A and the B. I will now come, let's say I come here now and do KQ over R squared, all squared, plus KQ over R squared, all squared. Now, plus, now notice something. This one now is, because I'm ignoring, let me first ignore before I start multiplying. Because they are positive charges, no need. If you remember why we started. So why we did this thing like this, that is for you to know how we moved. How we moved, the reason why we moved. So you can now see that everything here is the same thing as saying KQ over R squared all squared. Do you agree?
Yes. But this is distance.
See. They gave me Z here. Give me Z here. I don't know the distance, so give me Z here. Which means that if this is R, this is R, this is R, is the same. No confusion, no imagination. So if I put this, I'll now go and do plus. Notice something. This is everything with this, but it's being added together. So that means I'm going to be having inside this root, I'm going to be having 2. In fact, 2 everything on KQ over R squared all squared. Everything. Now notice something. The minute you do this, notice that this thing is looking like this thing. Do you agree? That means that E net now will be equals to root of this plus this will be 3 of it. All KQ over R squared all squared. So at this junction, we remember that the R squared that we are using here is because of the formula. We can now go back here, replace this R with Z. Please, if you start from beginning to confuse yourself or to quote all these things without knowing the way we did it, you will confuse yourself. Because if you try to start thinking without using the principle how we are going about it, you start imagining things inside it. So that is why I started it with physically how you should see it, what everything should be like. Go into it, then you now start to remember what each one is. So now that I've gotten to this junction, I can now start checking what my Q is. Q is positive, a proton. I can put, if I want, I can put value for proton there. The Z was not given. They did not give me distance. Let's finish. Can I connect?
Yes.
So in that case, my E net is going to be the same as saying 3 KQ all Z squared. Everything raised to power 1/2. Share your agree. Do you know the reason why everything is just power 2?
Yes.
That's our law, reciprocal law. That is what do we call fractional power law. Fractional power law that says that f raised to power 2 over k is the same as saying k root of m raised to power 2. So that is why I'm doing that. So now I've gotten to this junction. At this junction, I can decide to say that this is the same as saying 3 into 9 times 10 raised to power 9 times 1.6 times 10 raised to power minus 19 raised to power 2 over. Remember they did not give me distance, so share you know.
Yes.
Square. Raised to power 1/2. So times this for me. You can leave your answer at this junction, or you can leave it this way. But it looks as if something can simplify further.
You think I'm
It seems as if something can still go in. Okay, first of all, multiply this thing for me. Let me see what we have.
1.44 times 10 is
1.44
times 10 is minus 9.
minus 9 over z square shall be multiply by 3. Then, wait, so did you do okay? You just multiply this, shall be okay. R square then raised to power square root. Now, do you know that this 3 can go here now?
Yes.
Multiply for me. Let me see what you have. Whenever this kind of question is asked, they expect you to stop at this ratio. The electric field is on a ratio. That's what you need to do. But I'm just solving for that just in case it's objective and you see something. Don't more.
4.32. 32 times 10 is minus 9.
4.32
times 10 is minus 9.
Let's go minus 10.
9.
9. Okay.
Minus 9.
Okay, minus 9. All let's go 1/2. Shall we?
It's the power 2.
Okay. Okay. Okay, squared before and is over z, shall we? Z squared, shall we? 1/2. Somebody will think we are wrong. We are very correct. This is what is expected once it's triangle they did not give us this. Because the only problem, the reason why we are having this issue is because of this Z. So see what you do for me.
The power.
The power.
The one who said answer the one else.
Yeah, it's true. That's true because we've done this. But in this case, okay, it can also do the same thing. It can also do the same thing. It can also do the same thing as 3K. God bless that person.
Amen.
When I then gentle, God bless. So this will cancel this. So we are left with just this for this one. But let's continue to solve further. Because yes, because this now is affected. Pardon. See, do for me. Everything here times, square it. Then we know that this one raised to power 2 is going to be Z raised to power 4, shall we?
Including the threads.
Just do everything here for me. Square. Or do you know what we can do? Instead of suffering ourselves, let's do everything here. 9 times 10 raised to power 9 times 1.6 times 10 raised to power minus 19. All Z square raised to power 2 over 2. That is power law. Jackson.
Then the 3 also be raised to power.
No, now 3 is slicing everything here that is going to be raised to power 2.
But they have to cause me that inside that bracket.
Are you seeing what we are saying?
I think yes, in the walk too. He stopped at that 3.
This one?
Yes.
Can stop here.
That was the answers.
That's why it's more cook now. It's a special, Shabby.
Yes.
This one is tutorials. That's why it's more cook. See, what cook might give you that one. But in alternative, they might end up doing something like this. So see our problem. Let's look at this one. Let me hear your point. Okay, see the problem now. Let me solve the law now. Let me see something. This is the same as a distributing power. Sorry, I'm coming. Just one. So this is what I'm supposed to have. So punch this in for me now. Punch it for me.
1.44 times 10 is power minus 19. Minus 1.44.
Minus 9.
Minus 9, yes.
So please check your textbook. Did they just write 3K cube over Z square or 3 raised to power 1 over 2?
Yes.
Or they left the square roots here.
It's not in the textbook, in the workbook. They gave the answer of all of them. All of them.
As root what? Check.
It's not in the workbook. But I don't know.
But tell me what you saw there.
Answer is
No, the question you don't understand what I'm asking. What I'm asking is, the year limit as root 3K cube over Z square.
Yes.
You see what I left it as? Yes. Root 3K. Okay, if we are not going to leave our home like that, that means that this one is supposed to be. This one is supposed to be actual usually 3 raised to the power 1 over 2. Then times k cube over z square. Sure, you know that this is the same as that root. Are you alright? So please, I want you to solve your own further to this point. Remember and tell. Let's now solve when a is positive. There are vector quantities, but assuming it's the electric potential, because you notice automatically that the charges are the same, you just add it up. You understand? For electric potential, what you just need to do, see, V is not shortcut. See, V, to find V, you know that V is KQ over R, shall we? Yes. Do you remember? Yes. So it will be VA and then VB will be equals to KQ over R. Remember that this charge here is positive, this is positive, they are the same charge, the same charges. So you just plus the 2 because it's a scalar. Anytime you know something is a scalar quantity, just no need suffering or doing all this, just add up. That is how you go about scalar quantities. That is why that principle of superposition that just sums up charges work, because charge is a scalar quantity. So you just add up. Principle of superposition, you just add up. So this is going to be the same as saying just KQ over RZ plus KQ over Z. So the total prevalence will be equal to everything here 2 KQ over Z. Sure you know? No. Yes. Look at it, you see it. We better be knowing it. So everything here will just add up and you get this. That is it. So if you want to solve further, you can now remember that.
If you don't want to solve further,
okay, so that is for the potential for the first case. Let's quickly rush the second one. Question. Okay, that means what's the time? 3:47. I am the movie. We have time. No, not for you. Do you know the problem? The problem is that most of the questions, once we leave it, we don't remember to solve it. So we are having class on Monday by 11. Or B. We are having class on Monday by 11.
what is the link?
Or B. On Monday.
I'm just asking.
Okay, if there's lecture, that means after lecture. By that, there will be lecture on Monday. So please, let me know inconvenience you. Remind me, we have like 3 questions now with no solve. And if you don't remember it, I will remember it. So that we solve it. So somebody pray for us. Let's go.